Good morning to everyone. Today we are going to learn about some naming of organic compounds. In previous classes we also started the naming and we have completed some parts naming of hydrocarbons, especially alkanes, alkenes and alkynes. Today we are going to learn about the naming of alcohols, ethers, aldehydes and ketones. So 4 different types of compounds we will try to name. So let's start from the naming of alcohols. So alcohols are named by replacing the suffix ane with anol. That means in case of hydrocarbon or alkane, we had the suffix as ane. Like as here you can see ethane, CH3 or compound containing 2 carbon and rest of them are hydrogen. That means alkane with 2 carbons are named as ethane and the suffix can be considered as ane. This is the red symbol or red color. So the suffix is ane and that ane should be replaced in case of alcohol by anol. So this is our alcohol corresponding to 2 carbon atoms or containing 2 carbon atoms in the alcohol molecule. So we are naming, just we will replace the ane with anol. So what we are going to get? CH3 CH2OH, which corresponds to carbon containing alcohol, that will be renamed as ethane to ethanol. So just we will replace the ane with anol. But if we have 2 or more OH groups or hydroxyl groups in the compound or alcohol molecule, in that case we have to follow little bit different. That means if we have 2 or 3 or more or multiple hydroxyl group, in that case you must need to put the position and also you have to add some prefixes before the number of or before the alcohol molecule or alcohol hydroxyl group. If there is more than one hydroxyl group, that means the suffix is expanded to include a prefix that indicates the number of hydroxyl groups present. That means if you have 2 hydroxyl groups in a compound or in alcohol, in that case you have to write down anediol. That means di, then ane, normally we have read anol in case of alcohol. Now we are giving ane and di or tri and then all. Like this way, if you have 2 hydroxyl groups, in that case you will write down anediol and anetriol. That means di or tri or tetra, whatever, how many hydroxyl groups we have, depending on that we will replace the ane of the alkane by anediol or triol or tetraol if we have multiple hydroxyl groups. Let's see an example. OH CH2 CH2 OH. That means we have 2 hydroxyl groups in the alcohol, this alcohol. So we have we can have the hydroxyl group here or here. So as this is the beginning, so I am not going to mention the number or whatever, just how many hydroxyl groups we have. Just we are going to learn how we can represent the presence of hydroxyl groups or how many hydroxyl groups we have. So we have 2 hydroxyl groups, therefore we have 2 hydroxyl groups in the compound having 2 carbon atoms. So in case of alkane, we will rename or we will name the alkane as ethane, and now we are replacing ane with anediol because we have 2 hydroxyl groups. Now finally, what will be the name of this compound? 2 hydroxyl groups, therefore containing 2 carbon atoms, that will name as ethane. So ethane, and how many hydroxyl groups? 2. Then it will be diol. So di, or if we have 3, then tri. So we are naming that ethanediol. Again, if you have 3 carbons and 3 hydroxyl groups, here we are writing OH, this is CH2OH. That means this OH is bonded to this carbon and another OH bonded to this carbon. So 3 hydroxyl groups are bonded with 3 carbon atoms. So we have 3 hydroxyl groups in a alcohol. So we are going to name the alcohol as how many carbons we have in the alcohol molecule, that is 3. So that will correspond to the propane, and we will replace the ane here, prop ane, and how many hydroxyl groups? Triol. So though this is not the perfect name according to the IUPAC, because we need to mention the position of the hydroxyl groups, but as a general rule, if we have how many numbers of hydroxyl group, or if we have 1 or 2 hydroxyl groups, in that case how we can rename the alcohol molecule, that is our simple rule. Now let's see how we can name all of them. The position of the hydroxyl groups on the parent chain is or are. That means if you have a single hydroxyl group, then you need to mention only one position, and if you have multiple hydroxyl groups, then you need to mention the positions. So that we are using singular or plural, the position of the hydroxyl groups on the parent chain is or are indicated by placing the numbers corresponding to the location. So where the hydroxyl groups are present, you need to mention the position of the hydroxyl groups, and then use the formula rules what we have shown here. If you have 2 hydroxyl groups or 3 hydroxyl groups, whatever, so if we rename this compound perfectly according to the IUPAC rule, in that case we need to mention the position of the hydroxyl groups also. So 1, this is 2, and this is 3. So we have 3 hydroxyl groups in 3 different carbons of a propane molecule or propanol overall. So we will write down that 1, 2, 3 hydroxy, or like this way, or here we have write down that 1, 3 propane diol, and then for previous one we will write down that 1, 2, 3 propane triol. 1, 2, 3 propane triol. Previously we did not, for this name we did not mention the position, but now we have mentioned the position. So that is our exact name for the Iupac rule, or we should follow this numbering, because if you do not mention the position, then you do not know if this hydroxyl group is attached to this carbon or this carbon or this carbon. Even this hydroxyl group can be attached, 2 hydroxyl groups can be attached with these 2 single carbon. Therefore that is also can be considered as propane diol. But how we can differentiate? We must need to mention the position of the hydroxyl group, that if the hydroxyl group is present at the carbon 1, 2 or 3, or even in the same carbon. So you need to mention the position of the hydroxyl group, and then how many hydroxyl group are there, depending on, you have to write down the diol or triol in addition with the ane. So how many hydroxyl groups are present? The hydroxyl groups takes precedence over alkyl groups. That means if you have a alcohol molecule, or if you have a molecule with methyl functional or alkyl functional group, and also the hydroxyl group takes precedence over alkyl groups and halogen substituents. That means if any compound has alkyl halogen or alkyl replaced, and then or also halogen, alkyl substituent or halogen substituent, in that case you need to consider that compound. I need to mention clearly again. If you have a compound with alkyl substituent, halogen substituent, and must be hydroxyl group, so you will consider that compound as alcohol, neither alkane nor alkyl halide. So you need to consider that alkyl or halogen will be as substituent. So we will consider that hydroxyl group will take precedence over alkyl groups and halogen substituents. So, and also as well as double bonds in the numbering of the parent chain. So if you have hydroxyl group in a compound, it may have double bond halogen substituents or any other alkyl substituents. In that case, you need to consider that compound as alcohol, because we will show in later that the functional group, priority of functional group, will give you a chart that if there is any functional group in the priority ratings, which one should be given more priority. If more or two or more functional groups are present, then which one gets the more preference. You need to consider that compound as that functional group containing compound. So here we are mentioning that if you have a compound with hydroxyl group, alkyl functional group, that means some R functional group, or halogen, or even double bond, in that case you need to mention or you need to consider the compound as hydroxyl group or alcohol group or alcohol compound. So let's see, this is a compound containing halide group and also OH group. In that case, how we can name the compound? CH3, CH, Cl and CH2OH. So we have 3 carbon atoms, 1, 2, 3. So initially we need to consider that 3 carbon containing alkane corresponds to the propane. So we have one halogen substituent and another hydroxyl group. So from this rule we know that we have to give the preference over the hydroxyl group. So we do not need to consider this compound as alkyl halide, we will consider this compound as alcohol. So our compound should be, or parent compound should be considered as alcohol, and then our halogen or any other substituent what we have mentioned here, that should be considered as substituent. So what should be the name of this compound? So if we consider this is an alcohol compound, in that case you need to number the compound so that the position of the hydroxyl group is minimum. So here if you write down the position number 1, 2, 3, that would be the perfect naming numbering, or you can do other way, 1, 2, 3. So this chloro, that means position of chlorine, do not change, because if we number from right side or if we number from left side, both side we are getting the chlorine position 2 or chloro position 2. But as I have mentioned that as we are considering this compound as alcohol, then we need to number the compound from that side where the hydroxyl group substituent or alcoholic group substituent get the minimum number. So we cannot number this compound from the left side, because in that case the hydroxyl group gets the number 3. However, if we number from the right side, we can get the position of OH as 1. So the name of this compound should be, first mention the substituent with the position. So 2 chloro, and then this is the 3 carbon containing alcohol, that should be propanol, because it has only one hydroxyl group. That means previously I have mentioned, if we have one hydroxyl group, then we will change the suffix ane with anol. But if we have multiple substituents, that means multiple hydroxyl groups, in that case we will replace the ane with ane, what I have shown here, ane diol or triol, whatever we may need. So here the name of the compound becomes 2-chloro and 2-chloropropanol, because we have only one hydroxyl group. So now you may mention that we are not mentioning the position of hydroxyl group. As already I have mentioned in the last class, if we have any substituent or any functional group that is in the position 1 or in the first position, you don't need to mention the position of that substituent or the functional group. So we could write down that position of that compound or hydroxyl group 1, but that is not necessary. Okay, so you should not name this compound as 1-hydroxy-2-propyl chloride. 2-propyl chloride, because we cannot consider this compound as the alkyl halide. So I have mentioned here, you should not consider this compound as 1-hydroxy, this is numbering 1-hydroxy-2-propyl chloride. Like this way you cannot write down. Again, let's see another compound. So CH3, CHOH, CH2Cl. So in this case, that is also an alcohol, though this is in that position 2. You can consider the numbering either from this side, this 1, 2, 3, or 1, 2, 3. In that case, you can number from this side or this side. So what would be the, I have given you the naming, but why I have numbered from right side instead of left side? Anyone can tell me why I am not considering the numbering from left side?
So chlorine can have the lowest carbon
Exactly.
number?
Yes. Position of the chlorine can be minimum, and also if we write down the number or if we select the number from left side, OH position gets always 2, because this is in the 2 position. Either we number from left side or right side, both of them gets the OH. However, if we number the from left side, in that case chlorine is getting 3. In that case the numbering should not be perfect, so we should follow, so that this is our original compound or parent compound should be alcohol. So we are giving the preference first for the OH position. However, if we have another substituents, then we need to think about the position or summation of the positions of the substituents should be minimum. So we are numbering from right side, so we are getting 1 plus 2 equal 3, and if we number from this side, then 2 plus 3, that means becomes 5. So that is not perfect, so we should number from right side. So the overall name of the compound becomes, first mention the position of the substituent with the number of the position. So 1-chloro, and then, or one thing, maybe as this is in the 1 position, you may not need to mention the 1, so you can write down chloropropanol 2, that is also okay, or even 1-chloropropanol, that is also okay. But as I have mentioned in this previous name, I am not mentioning the position 1, so you can omit this 1. So that should be chloropropanol 2, not the 2-hydroxypropyl chloride, because we are giving the preference for the hydroxyl group to make the compound as alcohol, not the alkyl halide. Okay.
Can we write it as chloropropa 2 OL?
Propa 2
no OL.
2 nol.
Propa 2 all. Yes.
Propan 2 all. Yes, that is also okay. So propan 2 all. Okay. When both double bonds and hydroxyl groups are present. So if we have a alcohol containing double bond and also hydroxyl group, in that case you need to name little bit, you need to change the suffix little bit. As I have mentioned, if you have here hydroxyl group, not here, The position of the hydroxyl groups on the parent chain is indicated, not this name, where that was I have mentioned. If we have we need to give the preference. Okay, this is the hydroxyl group takes precedence over alkyl groups and halogen group substituents as well as double bonds. So I did not show any example if we have the double bonds there, because I want to show you a little bit more precisely. So if we have a double bond, when both double bonds and hydroxyl groups are present in a compound, that means with hydroxyl group, or should we consider that as alcohol or we should consider as alkene? If we have a double bond or triple bond, in that case, in the previous rule we have mentioned we should give the preference for the alcohol even if we have the alkyl group, halogen group or multiple bonds. In that case we will have to consider that compound as alcohol and rest of them need to be mentioned as substituent. Okay, so how we will name the suffix or prefix? So let's see. When both double bonds and hydroxyl groups are present, en suffix follows the parent chain. So first, in the parent chain, en suffix follows the parent chain directly. Here you can see one name, pentene, because we have a double bond. We have, in that case, normally to write down pentene we need to write down pentne. So we are writing, we have 5 carbon atoms in this compound containing a double bond, so that should be naturally as pentene if we do not have any other hydroxyl group. But actually, as we have one hydroxyl group, we need to consider this compound as alcohol, but you need to consider the double bond as the substituent. So you need to mention the position of the substituent and you need to change the suffix like this way. En suffix follows the parent chain. So this is our parent, it should be pentene, because 5 carbon containing compound pentene, and the ene, so we do not have the e at the end, so we will use only up to n, en. So the suffix follows the parent chain directly and the ol suffix follows the en suffix. So ol, as you have mentioned in the propan-2-ol. So exactly similar way I am showing here. So pentene 2-ol, so you need to mention the en to the parent compound or parent name, and then the position of the hydroxyl group as the, and the ol suffix follows the en suffix. So after en suffix, if you have the OH position at the number 1 position, in that case you don't need to mention the number. So in that case you can directly write down pentanol, pentanol. So you don't need to, but here we have the hydroxyl group in the 2 carbon, therefore we must need to mention the position of the hydroxyl group also. So what is the name of this compound? Let us see that hydroxyl group is attached to the 2nd carbon and the double bond is in between 2nd and 3rd. So this is our number 1, this is 2, 3, 4, 5. So we have 5 carbon atoms and the carbon-carbon double bond in between 3 and 4. So we should name or we should number the double bond as 3. So the double bond is in between 3 and 4. So the position of double bond is 3. So we are writing the name of this compound as 3-pentene, then position of the hydroxyl group 2, and then ol. So that is about the naming of the hydroxyl group. The location of the double bonds is or are, that means if you have multiple double bonds in that case you need to mention the location of the double bonds. In that case, if you have two double bonds, in that case we need to die in something like this, because in the last class I have mentioned if we have double bonds, two double bonds or three double bonds, in that case we have to mention die in or try in. So now we maybe we will not give you so difficult name for naming, because we can make very bigger compound, but naming of that compound is really difficult. So we don't need to think about that if we have 3 or 4 double bonds in a compound. So the location of the double bonds are indicated before the parent name as before, and the location of the hydroxyl groups are indicated between the En and Ol suffix. See below examples for. So here already I have mentioned the example, and you have seen the name. So here is another cyclic alcohol having the double bond. So in the naming of alkene, we have mentioned that if we have a cyclic compound, then we need to mention the word cyclo. We need to mention the cyclo in front of the alkene. But as this is an cyclic alkene, and then hydroxyl group, or overall this is an alcohol, so we have double bond and hydroxyl group. So here also similarly we have double bond and hydroxyl group, so we are considering the compound as alcohol, not as alkene. So we also consider this compound as alcohol, not the alkene. So we need to consider the alkene or double bond as substituent, and so write down the write down I think 2-pentene 2-ol. So I think it should be named as cyclo here, cyclo because otherwise it should be named like this way. So if we do not put the cyclo word in, okay, it is going outside. Why? Okay, so this is the hydroxyl compound containing a double bond. So mention the position of the double bond. So at which position? At second, because this is our hydroxyl position, so this would be the 1 position. What? That 2 should not be. Cyclopentene ol, because this is our 1 position, so the hydroxyl group is at the 1 position. So 2-cyclopentene ol. So that is the name of this compound. So double bond, this is the 2 and 3, in between 2 and 3 this is 1. So this is the compound 2-cyclopentene and ol, because if we need to mention the position of that hydroxyl group, in that case we should mention 1-ol, but actually this is not 2-cyclopentene ol, that is the name, because we don't need to mention the position of 1. Now what about the naming of ethers? Ethers is a compound or organic compound having a functional group oxygen, that means two single bond of oxygen is combined or shared with some other functional group. It can be R or AR. This can be AR or AR, that means alkyl group or aryl group. But one very interesting thing for naming of ethers, there is no exact rule from the Iupac. So you need to follow the trivial or normal naming what we are using. So just use what are the site or what the components in the two sides of the ether group. So you are only expected to know how to name ethers by their common names, because this is the common name, means you do not have the regular IUPAC rule, so you should use the normal common name. So how we do name the ether? Just use the two alkyl groups or aryl groups attached to the oxygen are put in alphabetical order. So here you have two different alkyl groups. So how we should name? This is a ethyl group, this is a methyl group. So alphabetically the groups comes ethyl first, so E comes first, and ethyl groups, so it should be named as ethyl methyl ether. So just use the common name. What are the groups? Two different groups attached to the oxygen. Just mention the name of that groups with the name ether at the end. So another thing I didn't mention, I think it should be like this way, even no space here. So that should be named here. So in IUPAC rule I have mentioned that the name should be just a single word, no space, only we can use some comma or hyphen. So there is no space in between the IUPAC names, but as this name is not from the Iupac, though it is authorized by the Iupac, but that is not the real rule from the Iupac. So these types of name should have some space, because we have two different groups. This is ethyl group, so ethyl, after that we are using one space and another space for methyl, and then finally we are writing that ether. So if you have two or more, we cannot have more than two. If we have the same side or same groups attached to the ether, in that case we need to write down di and then what are the groups. So we have two ethyl groups in the this ether compound, so we should write down diethyl ether. So that is the simple name of the ether, how we can name the compound ether. So just mention that or remember that this naming of ether do not follow the Iupac rules, and in case of Iupac rules I have mentioned that there should be no space, just use some comma and hyphen, but no space. But naming of ether, this comes from the trivial name or common names, so we can use a space to separate the parts or to separate the words. So if we have same groups to the side of the ether, then we will use di, and then if we do not have, then we will mention the groups depending on their alphabetical order. So ethyl methyl ether, that is the compound, and for this one diethyl ether. Now what or how we can name the aldehydes? So aldehydes have the CHO functional group. So already this functional group has one carbon. That means in previous classes or previous lectures I didn't have any functional group containing a carbon, but for aldehyde, or maybe in later I will show some other more ketone or carboxyl groups, carboxylic acid groups. So that types of functional group already have one carbon. So in these types of compounds we will name in a numbering in such a way that we will have the position of that functional group number 1. Aldehydes are named by replacing the suffix. So previously in case of alkane we have seen that the name suffix is ane. So methane, ethane, propane, always we have the suffix ane. Now if we want to name the aldehydes, in that case we will replace the ane with anal. That means if you have an aldehyde named or containing one carbon, then the name of the compound or aldehyde becomes methanol. If you have two carbons, then it becomes ethanol. So like this way, just you need to replace the suffix ane with the suffix anal. So if there is more than one CISO group, actually an aldehyde can have maximum two aldehyde group or CISO group, because CISO can be at the end of the chain. So either at the first or last, only two ends can have the aldehyde group. So if there is more than one CISO group, the suffix is expanded to include a prefix that indicates the number of CISO groups. So suffix should add how many aldehyde groups you have. If you have two, then we need to replace the suffix ane with the ane dial. So if you have two aldehyde groups at the two ends, then you need to name the compound as anediol. So normally if you have one aldehyde group, then just replace the ane with anal, but if you have two, in that case you will write down the anediol. There should not be more than two of these groups in the parent chain, as they must occur at the ends. As already I have mentioned that for any aldehyde compound, we cannot have more than two aldehyde groups, because for any aldehyde compound, the functional group aldehyde functional group always takes the position number 1. So that can be at the first or last. So that can be just two ends, not always one, because if we have two aldehyde groups, then one should be at the first position and other should be have some other numbers. So this can have only at the end of the chain. So there is no other way that we can put more aldehyde groups or CISO groups in a compound more than 2. So it is not necessary to indicate the position of the CISO group, because this group will be at the end of the parent chain and its carbon is automatically assigned as C1. So naturally, if you have, or normally if you have only one aldehyde group, in that case you don't need to mention the position of the aldehyde group. But if you have two, in that case one should be numbered as 1 and then rest of them will go for other one. However, in that case just use the number, but here we don't need to mention the position 1, because always the aldehyde group sit at the end of the chain. So this can be named as CH3, CH2, CISO. This is propanol, because we have only one aldehyde group and that contains 3 carbons, 1, 2, 3. So it has 3 carbon atoms and we can write down the name of this compound as propanol. Okay, the carbonyl group takes precedence over alkyl groups and halogen substituents as well as double bonds in the numbering of the parent chain. So if the aldehyde compound has either alkyl group or halide group or double bond, in that case you need to consider the compound as aldehyde instead of other functional groups or side chains, except later I will mention for carboxylic acids. If it has a carboxylic acid group, in that case we will need to give the preference for the carboxylic acid group, but otherwise we will give the preference for the aldehyde group. So this is a compound, it has alkyl halide. So this is alkyl group, this is halide group. So this compound should be considered, and also we have a aldehyde group. So we have 3 different types of functional groups, alkyl halide or substituent, and then halide, and then aldehyde. So 3 different types of substituents we can consider. However, we need to mention you need to consider this compound as aldehyde, because from the rule we have mentioned that the aldehyde group will get the precedence over other compounds functional groups or substituents like as halide, alkyl or double bonds, like as what we have mentioned for first one, what we have discussed about alcohols. So in case of alcohol we have found, and even if the aldehyde has the alcohol, in that case we also give the preference for aldehyde. So let's start, or let's think about how we can name the compound. So as we have mentioned that the aldehyde group sits at the end, so always we need to give the number 1 position for the aldehyde group. So 1, and then 2, and then 3, and CH3 and Cl. These are the 2 substituents. So 2 substituents CH3 and Cl. So we need to mention the position of the 2 substituents, or we need to consider this methyl alchlorine or chloro as substituents. So you need to mention the position of the substituents 2 chloro and 2 methyl. 2 chloro 2 methyl propanel. So here you can also see that we have followed the alphabetical order. We have 2 substituents, chloro and methyl. So chloro C comes first, so we are writing 2 chloro, and methyl M comes later compared to C, therefore we are writing the 2 chloro first and then 2 methyl, and then we have only 1 aldehyde group, so that is the propanel. So 3 carbon atom, so we writing the 2 chloro 2 methyl propanel, and this is the another compound. So if we have double bond, that also we will consider that this is an aldehyde. So just give the number 1, 2, 3 and 4. So this is our substituent or side chain. So mention the position of the side chain 3 methyl and then 3 butanol. So position of the double bond and position of the substituents. So this is the position of substituent 3 methyl and 3 butanol. This is the name of the compound. And when both double bonds and carbonyl groups are present, the En suffix follows the parent chain directly, and the Al suffix follows the En suffix. Notice that E is left off. Previously, as we have mentioned, we do not have the E. Notice that the E is left off, En instead of Ene. So we don't write down Ene, so we need to write down the En only. The location of the double bonds is or are indicated before the parent name as before, and Al suffix follows the En suffix directly. So okay, I do not have any compound name here with including 2 double bonds, so I am not showing you here. Just simply this is the 1 position, and this is 1, 2, 3, in between 2, 3 and 4, so the position of the 3 butanol. Anyway, and I do not have more times, so just let's see last one. There are a couple of common names. Yes, for some aldehyde we can use some common names. Sometimes these common names are also accepted, like as this is the 2 carbon containing aldehyde. So from the rule of Iupac we can write down the name of this compound as ethanol, but it has a common name acetaldehyde. So this can be written as acetaldehyde or methanol. This is 1 carbon containing aldehyde, so that can be named as methanol, or it has a common name formaldehyde. Even this can be write down as benzaldehyde. So some common names for few compounds are also accepted. So we can write down the common name of these compounds also, but not always, but try to write down the name of IUPAC. If I precisely mention that you need to write down the common names, then you should write down. But I think I should not mention. I always give the preference over the IUPAC names. So try to remember the IUPAC rules and mention the name. So if I give you this compound, you will always mention ethanol, and for this compound you will always mention the methanol. And this is the end of today's class. If you have any question or comment regarding this, then you are welcome.